Hello everyone. Here is a two-dimensional motion problem or a projectile problem, and we are supposed to solve this problem, but this problem is linked and connected to the next problem, which is here. So these two problems are linked together. So here in this problem, there is a rescue plane flying at the altitude 235 meters above two mountain climbers here. And this rescue plane wants to drop supplies so that these supplies can land by these two mountain climbers. The horizontal velocity of the plane is given, which is 69.4 meters per second, and the plane is only flying in a horizontal dimension, right? So we are going to find how far in advance we need to, or the rescue plane needs to release the supplies or drop the supplies so that it can land by the climbers. Based on this information, we can just simply say this x, the distance, horizontal distance, is equal to v sub x times t. V sub x means the horizontal component of the velocity, right? And here we know that in projectile motion, the horizontal component will not change because we do not take into account the air resistance. So here that means if the vertical velocity, if the horizontal velocity here is 69.4 meters, at the end also the horizontal velocity will be 69.4 meters per second. So that means when this supplies lands, it will also have the horizontal velocity component at the end. All right, so we have got Vx, which is given, and we are supposed to find t from kinematic equations here. So we need to use kinematic equations that I have already written there. Three most important kinematic equations. So in this case, we can switch between vertical and horizontal analysis, and we can use our findings to the second dimension. Okay, now I will choose the first based on our information. We will use the first kinematic equation, and I will rearrange it in a way that suits vertical analysis. So that will be delta H instead of X, I'm talking about H now, is equal to a half of A will be G times t to the power of 2 plus V initial times t. Here I need to be specific. I need to write V initial y times t. That means I am only concerned with y, with the vertical dimension of the velocity. All right, and according to this problem, when you see that the plane does not have any vertical velocity, therefore this term will be equal to 0, right? It's a free fall motion with no initial vertical velocity because it doesn't have any angle. It's only moving horizontally. Then we need to set up our frame of reference, and our frame of reference, I will set it here, the beginning of the motion. Here will be 0, and this position will be negative 235 because it's below 0. This is y-axis, this is x-axis, right? And delta H is the difference between these two positions. That means the second position minus the first position, which will be negative 235 meters, is equal to a half of G, acceleration due to gravity, will be negative 9.8 8 meters per second squared. And if you are wondering why negative, I have explained the vectors and in the first video of this channel, frame of reference, so you can have a look and then see why do we need to give negative sign to the acceleration due to gravity, or g. That simply is because the direction is downward, and whenever the direction is upward, again in upward motion, again it will be negative, because in that case it will be deceleration, not acceleration. Okay, times t to the power of 2, and then from here I can get t is equal to 6.92 seconds. 6.92 seconds. All right, so this is the time. And now I can just simply say that x is equal to Vx, which we already have it, 69.4 meters per second, times t, the total time, which is 6.92 seconds, and the answer will be equal to 480.61 meters, right? So that is the answer. That means this x must be 48.61 meters, the horizontal distance, right? Okay, now we will move to the other problem. It's quite connected to the previous problem. It says that suppose the rescue plane of previous problem releases the supplies a horizontal distance of 425 meters in advance of the mountain climbers. What vertical velocity up or down should the supplies be given to that they arrive precisely at climber's position? So that means we need to give a vertical velocity to the supplies. So, but upward and downward, and what value? Which one? Upward or downward, and which value if? All right, so here the distance is given, and the horizontal velocity we already know, which is Vx is exactly the same, 69.4 meters per second. From this equation, x is equal to Vx times t, I can find simply time, the time it takes for the supplies to drop or to land. T will be equal to x divided by Vx. X is 425 meters divided by 69.4 meters per second, which the answer T will be equal to 6.12 seconds. So this is the time it takes for the supplies to land or to drop by the mountain climbers. But this is not what we were looking for. We are going to calculate the initial vertical velocity for the first part of the questions. Okay, it's asking for that. Okay, in this case, I will select the kinematic equation. I will write it, delta H is equal to a half of GT2 plus V y initial times t. Vy initial means the initial vertical velocity of the supplies. So that's why I write it Vyi. V sub yi. Yi means initial velocity towards y-axis. So in this case, again, the height is the same. And again, here I will plug in the formula. Negative 235 meters is equal to a half of negative 9.8 meters per second squared times t to the power of 2 will be equal to 6.12 seconds to the power of 2. Here we need a new time, new t. So we can't use the previous t time because the distance changed, so the time also will change, and we have already found the t plus v y initial times t, which is again 6.12 seconds. From this equation I can find that v y initial is equal to negative 8.41 meters per second. And why negative? Why became negative? Because that means this answer is correct, this angle is correct, this one is correct, and it should have a negative vertical velocity. That means here, this Vy at this beginning, Vy initial here, right? But this Vy initial, or this initial velocity towards y-axis or vertical axis, is not a uniform velocity. It has acceleration because it is free fall motion in this direction, right? So therefore Vy initial will be different from Vy final here, Vy final. And here the question is asking, with what speed do the supplies land? That means, what is the final velocity here, v? What is v? And we know v will land with an angle to the horizontal, right? So the second part, we are supposed to find the v. V is, what is the value of v? In order to find the value of v, we already have got the x component, which is already, we have got it, and that is 69.4 meters per second. But we also need to find Vy final here. We need to find this velocity. Vy final will be equal to, I just write f means final point when it lands. So v sub yf, let's say, this is the way we read, is equal to v sub y initial plus gt. This is the kinematic equation towards vertical axis, right? So that means it's equal to v initial, I already found it, is negative 8.41 meter per second, plus g is negative 9.8 meter per second squared, times, and t is, I already found the t here, 6.12 times 6.12 seconds. So the answer will be equal to v sub y final will be equal to negative 68.38 meter per second. That means the final velocity towards vertical axis has increased, but downward. That means negative means it's downward, right? And simply we can use the Pythagorean theorem to find the v. We already have got, this is vx, we already have got vy, and we can find v here. What is the value of velocity here, right? And then we can say v is equal to vx to the power of 2 plus y final to the power of 2. Because we need to find the final velocity of the supplies, yes, is equal to, here is negative 38.38 to the power of 2 plus 69.4 to the power of 2. Okay, and the answer V will be equal to 97.42 meters per second. This is the final answer for this problem. That means the final V will be, the value of final V will be like that. We can also find at what angle it will drop, because we already got the components, the value of components, so we can use arctang and we can find even the angle with the horizon that is landing. Okay, we can also calculate that. Okay, thanks for watching this video. If you found this video useful, please like and subscribe. Thank you.